Okay, Go from Node.js Devs. 30 minutes to give you the most value today. What we will be doing is, I'm doing an assumption here. Doing the assumption that you know how Node.js works. How many of you know how Node.js works? There are a few. Don't be shy. How many know how Node.js works? Quite a few. Yeah, that's good. Go is a language that is more or less a cousin, you could say, to Node.js. It was developed pretty much in the same time span. It was developed to fix the same itch or pain point, you could say, because it was in the early time of Web 2.0 where the need for lots of requests kind of skyrocketed in all the web. So today we will cover Go routines and channels. This is the way I think I can give you the most value for half an hour, because I will show you how we can fix one of the biggest pain points inside Node.js with Go routines and kind of what it solves. And I will touch on channels as well. What I will not teach you today is like syntax, generic types, idiomatic constructs, and also the error handling is a bit different in Go. But you don't have to have a complete own, lesson to figure out error handling, I think. I'm including this icon of ChatGPT because the point is like this. It's 2023. It's completely meaningless for me to, let's see here. Here is how you do a for each loop in Go. You can just do a for each loop in your favorite language and just say, show me this in Go, right? And that's, I hope, what you are already doing. So, comparing Node and Go, like the practical stuff, okay, so in Node we have NPM, which is pretty much the standard, but we have other package managers. In Go, the package manager kind of grew into the language, so it's part of the main command Go, so you are doing Go get and installing packages. Package JSON, the file that you put in the root in the project folder is basically called go.mod. Express.js, it's a de facto standard. It's actually so good that I would say more Node.js developers know how to use Express.js than even the built-in HTTP library, to be honest. And the thing that is the most like in Go is Gin. It's actually called Gingonic, but everyone is saying Gin. So Gingonic is, of course, a play on words, as you understand. They like to put the Go in their libraries in some cases. So, as I said, we will go for the most value you can get as a Node.js developer. So Go routines. Let's start with kind of the anatomy of almost every web request. Almost every web request is that you have something doing a web request, like a browser or curl or some other server that is using a web API. And then some data is fetched somewhere, and then it's a little bit restructured, and then you are throwing it out or sending it back to the requester, right? That's like the anatomy. And this is very important. I know that this is basic stuff, but this is very important to understand why Go routines. A little bit of history. So before Go, before Node.js, there was Web 1.0. And we had like Apache, we had other such technologies, which almost all of them used like, they took a thread. A thread is a resource in an operating system. It took a thread and just said that, okay, the whole request, as you said, okay, the point here is that the request is the arrow in this picture. The request here is the same arrow. Those old technologies took a thread and used that resource to help the user all the way from the question was sent or the request was sent and all the way to all the answers were sent back. And this is a very, very expensive way of doing things, and that's why I did a ship here. It's like renting a whole ship for just keeping this thread going. And what the web servers did back then was that they kind of reserved like maybe 100 threads or something, and they said that, okay, so when requests come, we will just assign a thread to this request, and that thread is going together with this request all the time till it's finished. Which means that if there were like 100 guys that pressed enter on your address at the same time, then of course they got one thread each, and they had a okay experience. When guy number 101 came and pressed enter basically at the same time, he had to wait until one of those other 100 were finished. And as I said, that's why we have the ship there. It's expensive, the thread. So, Node.js, what did change? And this is actually why Node.js kind of was invented, and the thing that it changed was like this. Okay, we are renting, we still need a boat because we are shipping data in this analogy. So we still need a boat. But what if we could do a schedule so that the boat is actually trying to transport things all the time? Because imagine like this situation with a ship, right? That the ship goes somewhere to a mine and picks up some iron, goes to a port where there is a factory doing nuts and bolts or something. And then the ship is staying that in the port for instance, 1 or 2 weeks, waiting for the bolts and nuts to be produced before it takes it and the order goes further to the next, station. That is what we had here. So the boat was like standing in the port almost all the time and just waiting for the next step to happen, even though the boat was costing rent all the time. So with Node.js, what we were doing is that we rented the ship, but we did the scheduler much, much better, so that the ship could, for instance, go and get some iron, deliver it to the port where the factory is that does nuts and bolts, but at the same time, it got something on the radio that some, I don't know, sheep farmers had some wool, so it went there, picked up the wool, and went to the field factory or something like that, I don't know. You understand? The boat was moving between different ports and moving different data in different contexts, because we had the schedule and we knew kind of we could use this resource in a much more efficient way. So the reason why I took you through all this is because I want to show you how Go does it and the difference to Go. And in Go, it's still like we are trying to be very, very sparsely use those ships. We can use more than one ship as compared to Go. But we are still trying to use the threads, the ships, much less. And what we are doing is instead that we are running Go routines. Because, okay, I'm going to go back to the events again. Imagine that someone changes an order here and suddenly says that, oh, I want 100 shiploads of nuts and bolts to finish my order. And the boat starts to go there and forth and just delivering nuts and bolts 100 times. What happens is that the whole schedule is completely destroyed, and everyone else does not get any service at all during this time, until all those nuts and bolts are ready and delivered for that single customer. So what does Go do then? What Go does is that it's interleaving, kind of. You never get into a situation where it's only serving one. But what it starts doing is that it starts to do some small deliveries and doing deliveries in between, which means that none of those concurrent flows or web requests or whatever we are mapping this to are standing completely still, but they are getting their fair share of processing power. So this is an extremely big difference. And if you know Node.js, how many of you have been able to how many of you had to rewrite the program because you starved the main thread at some point and needed to offload that calculation? A few of you at least. So, of course, I'm not saying this is a showstopper, and this is not a diss on Node.js or anything like that. It's just the fact that in Node.js you have to fix this separately, while in Go it might be that you just get this for free, basically. That's the point. So, I'm showing you a program which, it's a little bit absurd, but it would be much more absurd on Node.js. We have this function that says block 1 second, and it does exactly what it says. It's not like a sleep or anything. It's not like, that we just give up some time. it's actually, as you can see here, it's dead looping the CPU. It's dead looping the CPU. It's just standing in one place and saying, has 1 second passed, has 1 second passed, has 1 second passed, and like hundreds of thousands of times or even millions of times. It's putting up that question until 1 second has passed, and then it relieves, kind of, it releases and continues. So it's actually blocking 1 second. If we do this program, but the version in Node.js, what will happen in the program in Node.js if we 5 times, as you see that we have in the main function, 5 times, you see this word here. The go word is starting a go routine. So this means don't do this in the main thread, but kind of start it off and do it in another context. This is this keyword. So if we are doing this in Go, we will see what happens. But what happens in Node.js if we would do this? Someone that knows kind of on top of their head? Yes?
They just start, finish, start, finish.
Yes.
1 to 5 to 4.
Exactly. So it will actually take 5 seconds here, because with this kind of dead loop, this is kind of as if the program was doing a very, very heavy calculation or something like that. It's equivalent from the CPU perspective. If you are doing this, you are 5 times waiting for 1 second, which means that you don't get anything done. No requests, no anything, no things that are coming from the database. Nothing comes through during 5 seconds. While if we do it on Go, something completely else happens. When we start this program, we are seeing that it's starting units 0 to 4, as you can see here, in a basically random order, because it's how the scheduler starts up the Go routines, as you see, because of the Go keyword. Then it takes about 1 second at this arrow here. And then after that second, it finishes all of those Go routines. So even though we are kind of, munching, eating this CPU, the scheduler inside Go is still going between them and not blocking up everything, but trying to do the work that is to do and try to schedule it kind of fairly between them. So this is a very, very big difference. And if you translate it, even if I put this, call it idiot code, into a normal Go web service, for instance, and I started this, so this was going alongside normal web requests, nothing would block. You wouldn't get this effect that it's completely, blocked and nothing is happening. It would normally continue to respond. So it's a very, very big difference, and it's resolved this kind of pain point in Node.js. So one thing to understand here is that even on a laptop, you can run millions of Go routines. And if you are Node.js developers, you might not have that much of experience with threads. But I can tell you that if you start a few tens of thousands of threads on a normal computer like this, it will slow to a crawl more and more, and then you will have to basically turn it off on the button, because it will completely lock up after a while if you put too many threads. It will eat up both memory, but also the task switching will start to eat so much of the CPU time that it becomes completely unusable. While with Go routines, you can do millions of them, even on such a play device like this. So imagine what a good server can do, right? So it's a complete game changer. So the point was, if you go back, you remember how it was, I told you about Apache back in the good days when they were assigning a thread. If we are assigning 1 request per Go routine, and we can have millions of them, even on small devices, then this problem is solved, right? Right? Yeah. So, yes, so channels. The channels are the way of communicating between contexts. So if you have a normal web service, normally this might not even be a part that you have to touch, because in many cases you have web services that just work the request in their own context. In that case, you don't have to exchange any data between like concurrent contexts that are running. And when I'm saying context, I'm talking about those interleaves and changes that kind of make that several routines are running at the same time, right? But sometimes you have this very big need to actually exchange data between them, depending on what you're building for a system. So channels I'm likening them to a conveyor belt. First things first, a channel has a size. The default size is basically 0, which means that it's unbuffered. And a channel has a type, which means that it's a channel of strings, it's a channel of integers, it's a channel of person records or invoices. And you define it when you create the channel. You have one side that is putting those objects that are defined onto the channel. And you have another side where you kind of take the things off the channel, okay? So one Go routine has to be on one side and another Go routine has to be on another side to simplify things, basically. So what is the benefit of thinking about this? Okay, I won't take you down the road because it's too much telling, but in normal threads, people were fighting very hard with like locking schemes and stuff like that to synchronize this. That the channels are resolving in a very, very elegant way, I would say. When you put something on a channel, it's an atomic operation. So at 1, nanosecond, you're keeping something in your hand. In the next nanosecond, it's on the conveyor belt. And then it's available on the other side at once. And then at 1 nanosecond, it's on the conveyor belt. And in the next nanosecond, it's kind of in the other context. So that's what's happening with channels. I don't know if this picture is clear. Yeah?
If they are simplex, those channels, or duplex, can I send from both sides?
You can send from both sides, but I don't cover this in this talk. But I can answer more questions in the end, by the way. I forget.
Node.js is something similar like that in software, We can message from software and back.
It's possible. I will take the questions in the end. So, as I said, we have the arrows that represent like context, which might be, for instance, web request or something like that. And the thing here is, as we see, I even made it like that you see that the packages are of different types, right? So you can see that, for instance, the blue arrow is delivering the package to the green arrow. The green arrow is standing there waiting for it, and when the green arrow has packaged it in some present paper or something, it puts it on the next conveyor belt that is on that type, of that type. Some code. This, I hope that you can see the code up there on the smaller screen. First line is, of course, creating the channel. As you can see, we are at once defining what kind of type we are going to work with. In Go, by the way, this is a little bit like in TypeScript, you have the var declaration with a direct assignment. So if you put a colon equals, it's like, okay, it will infer whatever type it is. So this is a channel of type string. Then we have the Go keyword again. So you see here we have an anonymous function that is defined kind of inline. That we set Go in front of, which means that, okay, start doing this immediately and just kind of get out of my face. You understand what I mean? You just create this, get it running, but I don't want to see you anymore, okay? But the thing is here that, and here you can see also that, that my channel is taken into this context, right? So it's available here. And so if you're doing the arrow like this, you're doing an arrow that is going into the channel, then you are loading the channel with some data. In this case, we said that this must be strings. So we are taking the string hello world and we are pushing it into the channel. At this point, we are again doing this colon equals, which means that message, we are pulling something off the channel. And since the channel is of type string, message is, of course, a string. What happens in this program really, when you start it, is we create the channel. Then this is kind of started by put away and start this context somewhere else. And main continues at once. So main comes to this line here. And what happens if we are on the end of the conveyor belt where we are waiting for a package, but there is no package there yet? So nothing happens, we are still waiting for it, which means that if we didn't send this program would wait forever. It would never end because it would stand there at the conveyor belt waiting for this package to arrive, okay? So this is the most simple example we can see of doing channels, and you can see that it's exactly solving this thing, because this is an asynchronous thing. As I said, the main function said, get out of my face, but as they are sharing the channel, they can still talk to each other in some way. Of course, they can talk the other way as well, but that depends on how you write that function or that logic. So, does that mean that we are always in a risk of, starving, that if we forget to send something on the channel, that our program will kind of stop? No. So, there is a very, very nice language construction in Go. What's cool about Go, by the way, is that this is built into Go, which means that every Go programmer programs like this. There are other frameworks that are doing this for other languages, but then you have to say, okay, I'm a programmer that programs this language with this, framework. In Go, this is built in. So we are actually commenting out this sending on the channel, which means that we are starving it, on purpose, to see that what we want to do is happening. What we're doing is that we are using a select construct in Go. And the select construct makes kind of waits on any of whatever cases we have, which means that we are waiting for the my channel in the exact same way we did before, and we are ready to write it out should it arrive, right? But we also have this timer running, which means that if nothing happens for 10 seconds, then this will send a message, and then it will still be fulfilled, and the program will continue after 10 seconds after this line. So it will not, lock up. So that was the select thing. And okay, just the last thing is that the select, of course, also works on separate channels. So if we have two channels here, we have one string and one int, which means, of course, what we can put on or pull off of it. Then we have, okay, now brace yourselves. Again, we have two Go routines at this point. We are starting two functions. One is feeding the string channel, and one is feeding the integer channel. And as you can see, we are doing a very, very tight loop here. And at first sight, we might get this impression that what we are doing is we are just pushing in lots of things here. But that's the thing about the unbuffered channel, because I told you that the number of spaces on the conveyor belt is basically set to 0, which is that you can only have one element there, if you understand what I mean. So what will be happening here, you won't get, complete lunatic that is just pushing STR into this channel, because what happens is that it pushes the first STR into this channel on the conveyor belt in this picture. But then, when it comes to push the next one, it has to stop, it has to wait, because no one has yet, pulled it off yet. So, okay, so we have those two, and then basically this is a small loop of 5 times pull something off one of the channels. And the reason why I did it with like 2 channels was both to show that you can do select, but also that if there is something on both conveyor belts at the same time, the select will actually go for random. And there is a very good reason for that, because otherwise, if channel 1 would be very fast here and just push things on, it's a very big risk that you would get a complete starvation down on channel 2, because it will have all the time it will come things on channel 1. So the way they did it default, of course you can program around it to have some other behavior, but the default behavior in Go is very smart. It will actually just take one of them. So then over time when you are running this, you will get the effect that it will actually take from both channels and everything will kind of run on. So, summary. Go routines provide thread-like concurrency at an enormous scale. And this solves this problem that I said. It solves the starvation problem for Node.js, that if you do a big calculation or I don't know, if you use a template language, it takes too long to render the template and everyone else has to wait for that. This is not a problem in Go. We have channels that allow us to send data in a very safe and I would say very easy way as compared to all alternatives I have seen so far. And then, okay, so this is the last caveat kind of. it might feel that I was going through the goroutines and the channels, and now you are saying that, oh, this is a completely different beast. No. As I said from the beginning, I was showing you specifically where the biggest benefit is. Because normally, if you are a good Node.js programmer and you are using ChatGPT to translate code, then you can learn Go, in a few weeks, evenings kind of thing. Because it's so close when it comes to the rest of the things, when it comes to how the frameworks work and the middlewares in Gin compared to Express.js and such, you will find yourself, right at home. It's not a big thing. This is actually the thing that differs, and this is actually where you can have the huge benefit. So that was my talk. We have questions. Okay, yeah. Oh, yeah, the box.
May I have a question from this line?
You can use.
Oh, okay.
Talk to the box.
Are these channels able to do the communication between processes or only between goroutines within one process?
Inside the process.
Inside the process, okay,
Yes.
Thank you.
Okay, I have two questions about channels, I'd say. Did I get it right that the only way to get value from the Go routine is using channel? So it always goes to the next line of code, and then wherever this value is used, it stops there.
Again.
Yeah,
so
let me rephrase it.
Okay, so you are talking about the channel, and
Yeah, so when you have a Go routine which needs to kind of return a value, is channel the only way to get value out of there?
it's not. You can. No, it's not the only way of getting a value out of there, because if you're a programmer, you can put something on a queue and then get it from another queue or something. So there are always ways around it. But it's the default way and the natural way inside a Go program to use channels if you have different contexts that need to talk to each other. So much so that you even are encouraged to think about it like that, so you don't write the normal functions as they are, but rather draw the channels where you want them. And say, because the thing that you can do as well is that they are completely synchronized. You can have, for instance, if you notice that the feeder is much slower, for instance, than the consumer, then you can just fire up 5 feeders onto the same channel, and they are helping out to fill,
Mm-hmm.
Like Kafka consumers.
Yes.
Can I have
Yeah.
another question? Yeah. So what was it? Wait a second, I have just forgot it. Yeah, so does it mean that at one point there is only one channel that is running, if that's the right word?
Well, as you saw in the last example, we fired up 2 channels at once, and you can have basically until the memory stops of channels. It's just depending on your own fantasy how many channels. A channel is a resource that is much more lightweight than a thread. So you can have millions of them, of course, as I said. But it's just like a resource. It's just like you can have lots of files open, or you can have serial ports open, or whatever kind of resource that is.
I guess I'm confused on that, the fact that you don't need to lock any resources. I thought that it's working that because there is only one pipe through which anything goes. But you can call it different channels, but only one point of data is transferred at one moment. Didn't get it right?
What we're talking about here is the responsibility for data at any given time point in a timeline, right? This is actually the right way, I think, to see this. So at one point, you have some data in one context, a Go routine or whatever context, and then you want it over somewhere else. So at some point in time, you are saying that I'm giving over the responsibility for this over to the channel, which you predefined, and at some other point in time, someone else that is reading of the channel, that's another time point, it picks it off. The guarantee you have with channels is that the transfer is atomic. Okay, so there is no point in time, from the perspective of your program at least, there is no point in time where, for instance, you have half a structure on the channel and half a structure is still in your context. It's all or nothing.
Got it.
at one time. So that's why it kind of synchronizes in a way that makes other locking obsolete.
Speaking in Node.js language, is it like just a much more performant and optimized usage of something similar to worker threads in Node?
Yes.
Like, because you could do the same, right? But I understand that Go just makes it much, much more performant. I couldn't be able to run millions of worker threads with Node on my laptop, right?
Exactly. So in Node.js, it's like, okay, so we are acknowledging the fact in Node.js that very few things actually need some serious calculations. And that's why we don't have to think about it that much. And then we had like this fallback mechanism where you can have the worker threads. And it kind of solves 99.x% of all the cases. You don't have to think about it that much, actually, right? But what I tried to say in the talk is that with Go, you don't have to think about that much. If you need to, for instance, resize a picture in native Go code, that's okay to do in Go. It doesn't, stop your process. That's the point. And you can do it in massive scale as well. I don't know if that was a good answer for you, but...
I want just to add something. That worker threads and goroutine, it's a little bit different thing, yeah? Goroutine's more performant, actually, but also cool things that you can share context. So you write a program, it's like a scope with anonymous function is Node. You write the anonymous functions that have a parent scope. You can use variables from parent scope, blah, blah, blah. In goroutines, you can use the same. But with worker threads, nope. You can't share connections and etc. You need to add a lot of more effort. Yeah, for example, if you need to connect to database in worker threads and in your main threads and etc. So you need to make a lot of more effort than in Go. In Go, it's super simple.
So
like.
Do you mean that in Go, in a coroutine, I have access to a database connection in the main thread?
Yeah, you can share it.
If it's a pool.
Context, in one context.
Okay, so that's the main difference.
Yeah.
So in the first Go routine example that you shared, we were waiting for the Go routines to complete with time.sleep. So is there any API, like in other languages, where we need, if we want threads to complete, we join the main thread?
I think what you mean is this one, right?
Yeah,
Yes. The reason why the last line is here is because in Go, it's like this. When the main thread comes to an end, it doesn't matter how many millions of Go routines you have running. When the main thread dies, it terminates everything, okay? So this was just because I knew that this would take 1 second. So if I'm waiting for 2 seconds, I knew that it will, have time to finish this second. Mm-hmm. But the thing is that absolutely, if we were writing real code, of course we wouldn't write code like this to start with. But the thing is that we have super other mechanisms inside of Go to gather and, for instance, make sure that everything finished. That's very, very easy to do in Go. So that would be the natural way of doing this if I was writing real code.
Just if you could share the name of those APIs, those classes, I'll look them up.
Yeah.
Workgroups.
Yes, exactly.
Sorry?
Workgroups.
Work
Yes.
groups.
It's just a counter. Counter, yes, that you just, when you finish Go routine, you just decrease something. When you start Go routine, you increase. And at the end of the main thread, you just check that it's more than equal to 0. If it's equal to 0, you stop the program.
And that's all managed by Go. Got it.
It's the
So,
simplest way you go.
perfect.
But the typical way in Go as well is to use channels just to signalize something. You can have a bit, for instance, that you're just sending a bit just to say that now this happened at my place, and then the other guy knows that as well, right? So,
Got it. Thank you.
Firstly, thanks very much for the presentation. I'm really impressed how clean and powerful Go is, and I think Google has crafted it to be really elegant. And now I'm kind of inspired to grab my laptop and start programming Go this evening. It was really super awesome to look at that clean code. And my questions, building up on the first question, about returning a value from the Go routine. So does it have something like async await in JavaScript to kind of wait for the value and get the value without the use of a channel?
There is a little bit of a similarity, but the thing is that normally the channel is used not only in the end, for instance, of some processing or something. Typically, you have channels running that are, someone is putting something on there and someone is pulling off. So the async await is very, very centered about, okay, I'm doing something and now I have something to report, right? When you have awaited, you get some end result. But here it's rather the opposite way. It's like you have channels for them to live and to transfer things, as in Arthur is in a body all the time, to send messages and get something started over there, and it should live.
Okay, thank you. And second question about error handling. So what if a Go routine fails? Does it have something like exceptions? What does the language do?
This language does not. You can correct me if I'm wrong, but the language does not have exceptions if they haven't added it recently. And so it means that we are working only on exit codes, basically. So we are back in C days when it comes to that. But you can, of course, use, if you're reading the error code, you can use a channel to communicate that something has happened that is not good in somewhere, if you want to.
Okay, and last question, does Go run on a Raspberry Pi?
Yes.
Okay,